For a long time, artificial intelligence operated in strict silos. You had one model that could read text, another that could look at an image, and a third that could listen to audio. None of them could talk to each other organically. If you wanted to build an application that used both text and images, you had to manually wire these systems together using rigid, hard-coded pipelines. You were forced to act as the constant translator between distinct machines. Native multimodal AI moves away from this fragmentation. A single model now processes text, code, audio, and video simultaneously, removing the need for external translation layers between different file types. This shifts the engineering priority toward building systems capable of perceiving reality in all its mixed formats at exactly the same time. This means you can drop a 50-page PDF, a direct YouTube URL, and a folder of raw audio memos into the exact same prompt window, and the model understands the relationships between all of them. This is possible through a 1 million token context window. Notice how the tiny data footprint of text compares to the massive capacity needed for heavy files. You can process 9 hours of continuous audio or 1 hour of high-definition video in a single query. Processing files that massive gets expensive quickly. To solve this, developers use a technique called context caching. Once a large file is loaded into the model's memory, you can query it repeatedly while cutting the computational cost by 90%. But giving a model massive sensory input is only half the equation. Having a photographic memory and perfect hearing has no value if the system lacks an autonomous way to decide what to do with that information. This introduces the difference between a rigid workflow and an agentic loop. Think of an educational tool like Notebook LM, where you upload raw study materials and it generates podcasts and study guides. In an older workflow, you would hard-code a rule to always generate a summary. In an agentic loop, the AI decides for itself what materials to create. This autonomy is driven by a mechanism called function calling. Looking at this logic flowchart, the model sits at the center as a reasoning engine. Instead of a fixed script, you give it a toolkit of capabilities, like the ability to draw or the ability to speak, and let it choose which tool fits the task. For example, if the AI is analyzing a dense research paper and encounters a complex spatial concept, its reasoning engine determines that text is insufficient, actively routing the task to an image generation terminal to create an infographic. Alternatively, if it processes a 20-page historical timeline, it recognizes that the user would benefit more from an audio summary, shifting its execution pathway to trigger a text-to-speech model. By giving the AI a toolkit and the reasoning power to choose its tools, it stops acting as an obedient, step-by-step executor and becomes an active director of its own output. When the brain decides it needs a visual, it hands the task over to specialized native generation models, like the image generator known as Nano Banana 2. Because this generation model shares its underlying architecture with the main Gemini model, it has a built-in understanding of the physical world. It processes spatial logic natively, allowing it to correctly place navigational arrows along a logical route on a topographic map based on context. That physical understanding extends to academic tasks. You can upload an image of handwritten math homework, and the model will autonomously reason through the formulas and generate a new image with the correct mathematical notations drawn directly onto the page. The audio outputs rely on similar native integration. When the reasoning brain requests a multi-speaker format, advanced text-to-speech models parse the context to generate dynamic dialogue suitable for an educational podcast. These models possess granular control over tone and syntax, meaning you can instruct them to synthesize regional dialects, switching from a British accent to a distinct Bavarian one depending on the prompt. The final images and audio tracks are customized artifacts constructed with deep contextual awareness of the original source material. That loop-based reasoning is effective for deep analysis, but it's too slow for live, conversational interaction. When humans speak, we expect immediate reflexes. To achieve that speed, systems use tools like the Gemini 3.1 Flash Live API. Looking at this schematic, you can see that the model operates as a direct audio-to-audio engine. Audio goes directly into the central core, and audio comes directly out. It bypasses the traditional pipeline of converting speech to text, generating a response, and then synthesizing that text back into audio. By eliminating those intermediary steps, the system achieves near zero latency. You can speak to it naturally, interrupt it mid-sentence, and even turn on your camera so it can react to visual cues in real time. Erasing that latency is the final requirement for bridging the gap between mechanical processing and organic human conversation. This unified multimodal architecture is expanding across the developer ecosystem, removing the barriers between different types of data. We are seeing the rise of multimodal embeddings. This is a technique where text, audio, and video are mapped into a single shared vector space. It allows an application to run a search query using a picture to instantly retrieve a related audio clip or line of code. At the same time, these capabilities are migrating toward local, offline deployment. Open-weight models like Gemma 4 bring native image and video understanding directly to personal hardware without needing a cloud connection. These native, any-to-any multimodal agents are built to reason, design, speak, and listen simultaneously, merging previously separate digital tasks into a single cognitive flow. If you want to dive deeper into the world of tech, coding, and continuous learning, make sure to check out the Learn by Doing with Steven YouTube channel, which you can also find across other major platforms. And for great tech conversations while you're on the go, tune into the Steven Data Talk podcast, currently streaming on YouTube Music, Spotify, and everywhere else you get your podcasts. Thanks for watching.